All right, so today we're going to go over the classwork on solving quadratic equations by inspection, square roots, and factoring. So yesterday in class we worked on identifying what problems we would solve by inspection, meaning that we could look at it and simply tell the solutions by taking the square root of the constant. In order to use inspection, we wanted to make sure that there are only two terms. So we wouldn't use it for terms where we had the quadratic, the linear, and a constant term. But remember, generally solving, we would say an equation needs to be set equal to 0, right? But it doesn't always for inspection because we should be able to look at it and quickly take the square root. So when we see 81 minus n squared equals 0, if we think about taking the square root, remember we can just add the n squared term to the opposite side, that there are two solutions for 81. So what do you think that is, guys? 9 and negative 9. So these should be pretty easy to solve. I use this plus or minus sign, which means a positive 9 and a negative 9. Any questions about that? Okay. Since we have z squared equals 11, this is why memorizing your list of perfect squares is so important. Help me out, Antoine. Z squared equals 121, so what does z equal? Negative 11 and 11. So we can write that as positive or negative 11. Next, 16 equals y squared. Devin? Not quite. Square root of 16.
4 negative.
Positive and negative 4. Good. So it's not that you have to write it like that. You could also write it as 4, comma, negative 4. That would be okay too. B squared equals 1. Caitlin? Positive and negative 1. Good. So that's why we say inspection, because we really don't have to do any work. We can just inspect it, which means to really look at it and think about it and go, well, yeah, I know the square root of 36, so I can find my two values. And lastly, Jakia, c squared minus 36 equals 0, so c is equal to 6 and, good job, positive and negative 6. So those are pretty easy, right? All right, so when you look at a set of problems, what you want to do is go through and say, well, are there any I can just solve by inspection real quick? Because if so, that's the easiest ones. Next, we have square roots. So remember, we're going to solve these algebraically by undoing the operations being done to g. So to do so, we want to start outside of the grouping here that's squared, meaning we need to get rid of the minus 8. The inverse of subtracting 8 would be to add 8. Good. So we're going to add 8 to both sides. When we do that, that leaves us with the quantity g plus 2 squared is equal to 8. And what next? We take, good job, the square root of both sides. But again, just like we did with inspection, we need to remember that we have two possible solutions once we take the square root. So over here, when we took the square root of n squared, n could have been a positive 9 or a negative 9. Over here, the square root of g plus 2 could be a positive or a negative square root of 8. But we all remember how to simplify. Hopefully you have that memorized still. What's the square root of 8? All right, so no go. So let's look at this. The square root of 8 is the square root of 2 times 2 times 2. Remember, when you're taking a square root, you're looking for a group of 2 of the same factors. Y'all remember doing that? What's the square root of 8? 2 square roots of 2. Y'all remember that? I made y'all do it over and over. No? All right, so do it anyway. Square root of 8 is 2 square roots of 2. Memorize that one, okay? So we have positive or negative 2 square roots of 2. Anything that ends up in a radical, if it can be simplified, we need to simplify it. And then last step would be to, very good, subtract 2. So if we subtract 2 from both sides, we're going to have g is equal to negative 2, which is this number you just subtracted, plus or minus 2 square roots of 2. So we get an irrational value. That just means when it hits the x-axis, it hits with some funky decimal value. But this is how we would leave our answer. Do not give me a decimal answer. All right? Next, looking at 150 equals r squared. In order to solve this, we would want a positive r squared value. So I'm actually going to add r squared to the opposite side, but then rewrite it with r squared on the left, which is totally fine. R squared equals 150. So really there's only one step to solve for r, and that's to do what? Very good, take the square root. When we do so, we have positive or negative. Don't forget that step. But we got to think about what are the factors of 150. We got to simplify that. 50 is made up of what two factors? Try 10 and 15. 10 breaks down to 2 and 5. And then 15 breaks down to 5 and 3. And then we have a group. So what are we going to have? Go ahead, Antoine. 5 square root of 6. And that's it. R is equal to positive or negative 5 square root of 6. Okay? It's just kind of putting it all together, right? Yeah. It just takes practice, that's all. Y'all can do it. So next, if we look at the quantity 2n plus 1 squared, what do you think we need to do? Nikita says to take the square root. Do y'all agree? So we want to take the square root of both sides. Taking the square root of a square drops the square. So we're just left with 2n plus 1 equals
4.
Plus or minus 4. Good, Andrea. Plus or minus 4. So that means we have 2n plus 1 equals positive 4. And 2n plus 1 equals negative 4. Can y'all each solve those now? Just solve your two equations, you've got your two solutions. So after solving each of those, and I don't know why I did divide by 3 right there. That should have been 2. Sorry. Our two solutions would be 3 halves and negative 5 halves. 3 halves and negative 5 halves. So again, what were our steps? Take the square root. Simplify your radical, but don't forget your plus or minus. And then we just broke it into two equations. 2n plus 1 equals positive 4, and 2n plus 1 equals negative 4. And then just solve each of those. That's not too bad, is it? So how do you think we're going to solve this next one? Yep. Take the square root of both sides. Well, that means we can break it down, right? So I want you to think, what factors make up 12? 6 and 2, but is one of our, can we create a set where a factor is a perfect square? 3 and 4, right? So if it's 3 and 4, and we take the square root of 4, the square root of 4 is 2. So y'all agree that's 2 square roots of 3? All right. So we have positive or negative, plus or minus there, 2 square roots of 3. Our last step would be to not subtract it, but add the 5. Since it's minus 5, to eliminate this from the left side, we want to add 5. Now what I want you to keep in mind is you cannot add an integer to a term with a radical. So all we're going to have is 5 plus or minus 2 square roots of 3. They're not like terms. Okay? And that's it. Okay? Alright, so for this one here, we're going to come back to this in just a minute. It involves a little more work because I want to talk about what it means when we graph it. So let's pick back up in factoring, with factoring. Factoring yesterday, we did the first two. Were you not done copying? No, not done? It's okay. You go ahead, because we already did the first two that I had written in this box. Of course, yours might be written in a different order, and that's fine, but I already worked two of them. I'll slide this down just a bit. So for g squared minus g minus 42 equals 0, we ended with that one yesterday, but the bell is about to ring. So make sure you got all of that down. So recall, you can use your diamond method or just use trial and error. Just think, well, what terms do I multiply to get g squared? G and g. Then what terms do I multiply to get negative 42? 6 and a negative 7. And then we check it. Remember doing your double distribution. A lot of you have already known FOIL. So if you think about your FOIL process, your first terms give you your g squared, your inner and your outer. 6g minus 7g is your negative 1g. And then 6 times negative 7 is negative 42. So remember here, one thing we didn't put was that really where our answers come from are setting each factor equal to 0. Right? Remember we talked about your 0 multiplication property. So we'd have to subtract 6 and then add 7. So our two solutions are negative 6 and positive 7. So what do we need to do to this next one? G squared plus 2g equals 120. Good, Jessica. We want to subtract the 120. But remember, these aren't like terms, so we're just going to say g squared plus 2g minus 120 equals 0. What would go at the top of our x? A negative 120. You agree, Naquans? What goes at the bottom, Naquan? You're positive 2 here. Don't forget that C goes on top and B on the bottom. Now, what factors can I break this down into that will combine to give me 2? 12 and 10. But one of them needs to be negative. We need to end up with a positive 2. So we need a positive 12 minus 10. Agreed? All right, so we're going to use these right here to create our factors. So, Savannah, one factor is what? Good job. And the other factor, Jasmine? Good job. Equals 0. So now if I set each of these factors equal to 0, then what is g equal to? Let's see here. Nyla? Very good. You said negative 12 and? Is it going to be negative 10? You agree we have to add 10 to both sides? So negative 12 and a positive 10. All right. So what I want to be really clear is understanding what in the world are we solving for. Just as a reminder, we've been talking about this. When we solve, what are we actually looking for? The zeros. Very good. So specifically, that means where the graph does what? Intersects the x-axis. Good. So do y'all recall how to solve these? How to factor them? All right, so this is what I'm going to show you because some of you have forgotten how to factor using your diamond method or your box method. So what I'm going to do is just go ahead and teach you trial and error like I did with the other ones. So what I want you to think about are these two terms, when multiplied, have to result in 3r squared. We're going to have an r in each one. What two numbers do I multiply to get 3? 3 and 1. Good job. So I'm going to leave that 3 and a 1. So if this is a negative, what has to be true about our signs here? 1 has to be negative and 1 has to be positive. Good. So I don't know if this is right yet, but I'm going to put in a positive and a negative. I don't know if it's in the right spot. I might have to switch them around. But then I think of my factors of my C. So we're kind of still doing the same thing we were doing with the X method. For the 5, it's a prime number. Its only factors are 1 and 5. So I'll just put a 5 here and a 1 here, just to check it, just to try it. So it's called trial and error for a reason. You try it. Sometimes it doesn't work, so you just switch stuff around. So let's see if when we do our chin and grin check, if we get our negative 14, meaning our outer and our inner. So if I do outer and inner, what's 5 times 1r? 5r. What is 3r times negative 1? Negative 3r. When I combine 5r and negative 3r, do I get negative 14? I don't. I got the wrong number. So what I want to do is switch the 1 and 5. So I did this on purpose so y'all would see. 1 and 5. The more you do this, the more your brain figures out where to put them without having to think much about it. Because when I look at this, I automatically think, what I'm really doing is my A times C thing, right? So what is 3 times 5? 15. I'm trying to get a 14. I'm going to end up needing a 15 and a 1 to make 14. Okay, India? I need a 15 and a 1 to make 14. So now, do I have it right? If I do my inner, what's 1 times 1r? 1r. What is 3r times negative 5? Negative 15r. What does that give me when I combine them? Negative 14r. So that means my factors are correct. Okay? So again, 3r times r is 3r squared. My 1 times negative 5 gives me my negative 5. But now I have stuff in the right place so that when I do inner and outer, I can get my negative 14r. Now why is that helpful? Because now all I have to do is set each factor equal to 0. So 3r plus 1 equals 0. What do I have to do to solve for r?
Minus 1.
Subtract 1, then what? Divide by 3. So I hope that some of y'all will get to the point where you can kind of do that in your head. Because you know how we switch it when it comes out of the factor? Again, like up here at g plus 12 and g minus 10, we see plus 12, but our solution was negative 12. Are y'all catching that, Tamisha? If our factor was g plus 12, our factor is negative, or our solution rather is negative 12. If our factor has minus 10, our solution's positive 10. So if we have plus 1, but there's a number in front, it's kind of reverse bottoms up, right? So you have to switch it just like we do here, but then you divide by the number in front. So negative 1/3. This one here for r minus 5, our solution would be, it'd be what? What would it be? 1. Yeah, the other one would be positive 5. So negative 1/3 is the solution, and positive 5 is the solution. That looks weird. Negative 1/3 and 5. So this last one involves something a little different. We could try to do it the same way, but does anybody notice anything about these 3 terms? Andrea, do you? Look at 2p squared, 6p, and 36. Jakia, what do they have in common? A 2, good. So I can factor out a 2. So remember, what goes in parentheses is what you get when you divide out that 2. So what is 2p squared divided by 2? Just p squared minus, good, 3p minus 18, good. All right, now we have just a general trinomial. Our a value is equal to 1, so it should factor like this. Yes, ma'am. So p squared is made up of p and p. I just split it in half, split my exponent, right? P and p. I need a negative 18, or I need to think of factors of negative 18. So what are my signs going to be if my last term is a negative 18? Good job. A positive and a negative. And can y'all figure out what factors we're going to end up using? Because our goal is to end up with our inner term being a negative 3, right? So what factors of 18 do you think we could combine, in this case subtract, to make a negative 3? 3 and 6. Good job. So which is going to go where? Is our 6 positive? So do we want 6 minus 3, or do we want negative 6 plus 3? Negative 6 plus 3, right? Y'all see that? So let's see if it works. We've got p times p is p squared. Our inner terms, 3p minus 6p is negative 3p, and then 3 times negative 6 is negative 18. So that works. So what are our solutions? Remember, you just switch them, right? So if you set p plus 3 equal to 0, it's going to be a negative 3. If you set p minus 6 equal to 0, it's going to be a positive 6. Got that? All right. So this problem right here is a little complex. So I'm going to teach you how to use square roots to find one solution, but I want to talk real quick about the graph. So if everyone will go to y equals in your calculator, I want to show you something. What I want you to see when we graph this is that you may have more than one solution. As in, if we do this by taking square roots, we're only going to end up with one solution, okay? So again, let me just show you that real quick. Let's talk about solving this and finding a solution by square roots, okay? If we were to take the square root of both sides, what would that leave us with? Good. Equals. Right? Square roots just drop the radical. This is z. Sorry. All right. So remember, when you're solving equations with the variable on both sides, your objective is to get your z's on the same side and to get your integers on the same side. So what does that leave us with? What's 3z minus 1z? So 2z equals 4 plus 5 is 9. And then if we divide by 2, we get 9 halves. Which means what? 9 halves is, as a decimal is what? Very good, 4.5. So what that means is I would expect my parabola to cross the x-axis rather, halfway between 4 and 5. All right? So let's talk about setting this equal to 0. In order to set this equation equal to 0 from start, I can take this whole term and move it to the opposite side. When I do that, I have the quantity 3z minus 5 squared. If I take this whole term, it's a positive term right now. If I take it over, I have to subtract it. And now it would be equal to 0. So what I want us to do is go to y1 in our calculator, clear out anything you already have in there. Oops. And type this in. But of course, in place of z, we use x. Oops, not that. Oops. So 3x minus 5 squared minus the quantity z plus 4 squared. When you have it typed in, we're just typing in right here on the paper. Everyone there? And then we hit graph. Is that a what? Z? Yeah, it's a Z. If you hit zoom 6, it should. Hit zoom 6. Alright, so it needs to look like this. Everybody check your neighbor, make sure they have it typed in right. What's funny? Alright, so did it cross at 4.5? Alright, guys, why are y'all having trouble typing it in? What's going on? Did you hit Zoom 6? If you hit Zoom 6, it'll change your viewing window to a standard viewing window. Okay? Alright, so let's go, guys, so I can wrap this video up. It's already 25 minutes. So I see that it crosses at, it looks like 4.5, right? Let's find our zeros. Do y'all recall how to do that? We go to Y2, put in 0. Actually, what I want you to do is move your cursor over here to the left and hit enter one time. What it'll do is make a bold line right there. And then when I graph it, I actually see y equals 0 graphed. Okay? And then I hit second trace 5. Right now, where's your y-intercept? Oh, shoot, wrong question. Where is your little cursor on your calculator? He's at 0, 9, which is up here at the y-intercept, right? So you want to hit your right arrow to bring them down and hit enter, enter, enter. That's the other solution that we don't get when all we do is take the square root. So what I'm going to allow you to do is solve it like this, but find the other one by graphing. If not, it's a much more involved process of multiplying out by both binomials, setting it equal to 0, and then factoring. There is another way, but if y'all are comfortable with square roots and solving it this way, I'll let you find one solution by square roots and the other by graphing. Now, 0.25, think about that. That's a quarter, right? Isn't a quarter 0.25 or 25 cents, right? What is that number as a fraction?
1/4.
1/4. Good. And if we forget, I need you to focus. If we forget, we can type in 0.25 and hit math, enter, enter. If we get a decimal value we don't recognize. But that means that not only is 9/2 a solution, but 1/4 is a solution also. So we have to get the second solution by graphing. So I'm going to put up here, second by graphing and finding the 0. And y'all should remember that process because we just tested on it. All right, any questions?